Okay, I think I can start. Welcome, everybody. I'm Holly Cummins. I'm an engineer working for Red Hat. I help build Quarkus. Probably some of you saw, I don't quite know how, but while we were waiting to start, there was an AV glitch. And so my slides, the colors inverted. So that red hat there, which is, well, you have to use your imagination to see that it's a red hat, but a few moments ago it was a blue hat, which would have been quite surprising for some of my colleagues who are in the audience. So before I started working for Quarkus, I was a consultant. And of course, a lot of the teams that I was working with did microservices, because everybody's doing microservices. But the teams seemed to keep having the same challenges over and over again. And what they were really struggling with was, I've switched to microservices. It's supposed to make me give me better business agility. It's supposed to make everything easier. But I can make sure that my part works. But I don't really know how to make sure my whole system works unless I test everything together, at which point I've lost a lot of the benefits of microservices. At that point, what I have is a monolith, which is really, really hard and expensive and annoying to stand up. And I heard a rule of thumb once from another consultant, and he said when he would go and visit a new client who was doing microservices, with microservices, the dream is that you're able to deploy each microservice independently. That's why you've separated them, so that you can have that faster deploy time at an individual level. So he would look at the system, and he would just look at the version numbers. And if every microservice had the same version number, then he knew that this wasn't really a microservices system. This was something that was being treated as a single unit, but with distributed connections in between. So what he really would want to see is, instead of something like this, he'd want to see something more like this, where you do see that the things are evolving independently, and each microservice is able to evolve at its own pace. So quick show of hands. How many of you are doing microservices architecture, microservices development? Almost everybody. That makes sense, because the monolith people are in a different room going, we don't need to go to this talk. So, in the microservices people, how many of you have, whoops, wrong way. How many of you have a system that looks more like this? A small number. And how many of you are, more of you are, so that's a good thing, that you are sort of in this state where you're able to deploy independently. Because what this really shows, I think, when you have that ability to deploy independently, what that means is that you have confidence in how the individual services are tested, and you are able to take an individual service and deploy it without having to bring everything else along with it. Now, for those of you who have this kind of state, how many of you have multiple versions of a service running at the same time? Two brave people. That's when you're really living the dream, I think, is that you have enough of a handle on the combinatorics of your testing that you're able to support multiple different versions and have that evolution. But what often happens instead is, even if we're able to deploy with multiple versions, we don't really know whether things work together unless we test them together. So in the deploy pipeline, what we sometimes see is the deploy pipeline ensures that everything gets released at the same time, just in case there might be some incompatibility, because we want to discover those problems by doing end-to-end testing at deploy time. And so if we have this kind of system, it's a good indicator that you're probably too dependent on end-to-end testing. But there's a really good reason why teams are dependent on end-to-end testing, which is, if you just test in isolation, usually that's not good enough. And the reason is going back to some of those challenges that teams have, because a microservices system is definitely distributed. And I think we sometimes assume that because distributed and decoupled start with the same letter, if we're distributed, we're magically decoupled. But actually, it really doesn't work like that. And quite often we can get these quite spaghetti architectures, even though we're paying the tax of having network communication for all of our process requests. And so one of the first microservices projects I did, I got off the plane. It was a troubled project, so they'd flown me in, and pretty much the first thing they said to me was, every time we touch one microservice, all of the others break. Which, of course, is the opposite of what's supposed to happen with microservices. With microservices, it's supposed to be that you can touch one and it's isolated. But the problem is, this thing, it's going to be a system. There is going to be communication between the microservices, because otherwise it's not a system. Otherwise, they don't help each other, they don't talk to each other. And as soon as you have communication, you have the potential for misunderstanding. And so the problems happen because maybe we weren't clear about what we expected the other microservices to do, or we made a change that we thought didn't affect anybody else, but it did affect anybody else. And sometimes these changes seem like really good changes. So, for example, one of the main sources of defects that we saw was typo corrections. So the developer would spot that there was a typo, they would fix it, and then there would be chaos through the rest of the system. And sometimes that chaos was only discovered quite late in the cycle when we started doing the end-to-end testing. And there can be more subtle misunderstandings as well. So things like, how do we handle errors? That's kind of not the thing that you necessarily want to be having big design discussions about, because they're errors, they're boring, you want them to go away. But they can cause quite sort of subtle, nasty problems when your system does start hitting those error conditions. And I mentioned that testing in isolation just isn't enough. If we want to test a microservice in isolation, assuming it talks to the other microservices, what we have to do is we have to mock out our dependencies. And so how we usually do that is we either have a conversation with the other team, or we read their Swagger spec, and we get an understanding of what their service does. And we say, yeah, okay, I think I understand your API. And so in our tests, we write something that we think looks like their API. And this is great. It means we can get our tests going. But there's a problem. What if we got it wrong? What if reality actually is something quite different from what we mocked up? At that point, I'm really happy. My tests are green. I want to push to production. Unfortunately, when I push to production, reality is broken. So that's why you have a problem. So let me show you a quick little example of this. So what I've got, wrong way. I've got a little application. Let me make that a bit bigger. And the use case, the scenario, is that it's a sweater shop. So someone can come in and they can order a sweater. So they say, I would like a white sweater. They order, and nothing happens at all, which is not what I was expecting, because it's a live demo.
Have you tested?
Well, this is sort of a digression, but with live demos, there's a fine balance between testing enough that it works and testing enough that you leave the system in an unstable state where actually your testing makes it worse. So let me just see what's going on. Okay. So So that little service that I restarted is something that's supposed to make the demo pretty and informative. So we will see. So let's try again. All right, okay. So what we can see is this still doesn't work, but it doesn't work in the way that I expected, which is that my sweater order goes to my BFF, which is a cold person, and the order goes in with some JSON, and then it comes back out with a netty exception. What's going on? The problem is that this is a microservices system, and so far I only have one service running. So what I need to do is, wrong way. My next service is that there's a knitter service. So the knitter service takes an order for a sweater, and they knit the sweater. So I can do Quarkus dev here. And that should start. And now if I order a sweater, okay, so it still doesn't work, but it gets slightly further. So now you can see my order goes a bit further along the chain. It goes to the knitter service, but you can't knit a sweater without wool. So it still fails, and we still have a network exception. So the next thing I can do is I have a farmer service. So the farmer gets a request for wool. They go out, they shear a sheep, and then they return wool. So I can start this as well. So I've got Quarkus running there. So now if I, hooray! Okay, so now I have it successfully running, and if I order a sweater, a white sweater, I get a white sweater back. And you can see this was already a little bit annoying. I've only got 3 services in my system, but in order to try it out and play with it, I had to start, I had to do quite a lot of fussing around. And this is why microservices testing is annoying. So in my farmer service, I've got the model is that the farmer, oh, excuse me. The farmer goes out and they shear a sheep and they produce a skein of wool. And so this is the class for a skein of wool. A skein, I don't know why I use this word in my demo. It's quite an obscure English word. I think only people who knit would know this word. But apparently the translation is a kubari. So, but you can see as well, in my data model, my skein has a color, and then it's got the weight of wool. I live in England, so I use the British spelling. That might annoy some of my colleagues, so I can fix this. So I can do color, and then I can do my refactor. And then if I go back to my terminal, you can see I'm not a maniac. I do have unit tests. So like I've got my wool resource test here, which is making sure that everything is as it should be. My tests are passing. So just as a little sense check, just to make sure that my refactoring didn't mess anybody up, I can go back here and I can order another white sweater. And there's a problem. So there's no red lines here, but my new sweater is a totally undescribable sweater. We don't know what color it is. Sad lambda. I hope you appreciate, by the way, this is my favorite pun that I have ever made, because I've got the sheep connection and I've got the lambda computer connection. So what's going on? So my order goes through okay. So I say to the knitter, I want a white sweater. The knitter says to the farmer, I want white wool. And the farmer says, yep, here's your white wool. And then the knitter says, I have no idea what color we're dealing with. And you can see the problem is that spelling changed. And that's quite a subtle problem. It's the sort of problem that you will spend 4 hours going, why doesn't it work? Why doesn't it work? Why doesn't it work? Before you figure out that someone changed the spelling. So you could say, well, yes, but I think this just shows there's a problem with the unit tests. Why didn't you have a unit test that checked the spelling? So I could hard code that spelling into my unit test, but then all I'm really doing is making it I'm checking my Jackson serialization. So what's going on with my farmer is I return, in my wool resource, I return a skein. Jackson is taking care of serializing the skein. I don't really want my unit test to be testing Jackson because I trust Jackson, possibly. Possibly that's a mistake. Possibly I should be doing a little bit of validation there. So hard coding some of those things into the unit test doesn't really help. It doesn't give me the linkage to what the consumer expects. So, this is where what we really want is we want a contract test to give us that connection between the expectations that we have on the one side and the behavior that we have on the other side. So here, the contract test, it acts as a mock for the knitter and acts as a functional test for the farmer. And so that means if the contract test is okay, I've got a pretty good confidence that reality is going to be okay too. Because if the provider changes, then their tests are going to break because those don't work anymore. And similarly, if my code suddenly changes how it's using it, and it's using some endpoint that's not there, then my tests are going to break. So we've seen that already. So how many of you are familiar with the idea of the test pyramid? Most of you. So people sort of argue about the test pyramid and, should it have like a bulge in the middle and that kind of thing. But the basic ideas I think everybody agrees on, which is at the top of the pyramid, you have end-to-end tests. End-to-end tests are really good because they give you a lot of confidence that things actually work. But they're really annoying because they're so expensive to write, they're really fragile, you have to spend all this time maintaining them. And you saw, like, even just for my end-to-end tests, I had to start all of those services. And we see that was just 3 services. And we sometimes see, people come and talk to the Quarkus team and they say, like, I need to switch to Quarkus because I can't actually stand up my development stack on my laptop because I have 47 services just to try and see if this thing works. So switching to Quarkus is a good move, but they should also be looking at contract tests. So at the base of the test pyramid, you have unit tests. Unit tests are so cheap to write. They're so cheap to run. The only problem is that they don't necessarily give you that much confidence that anything works except for the little logic in your own service. So in the middle, sometimes we talk about integration tests in the middle, but I think what's most useful to have in the middle is contract tests. Because what contract tests give you is they give you a lot of the confidence of end-to-end tests, which means that you can shrink your end-to-end tests down to a tiny number of end-to-end tests. But they're as light and as easy and as quick to run as unit tests, which is pretty cool. A nice way of thinking about contract tests and sort of how they fit is by analogy with a fire alarm. So when you think about how do I know my fire alarm actually works, the best way to test a fire alarm, to give you the complete confidence that your fire alarm will go off if your house is on fire, is to set your house on fire. And as you sort of see the smoking remains of your house, if you hear beep, 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 then you know that your fire alarm works. There's a small problem, though, which is that your house has now been destroyed. It's so expensive to run that it doesn't really matter that it gives you good confidence. On the other hand, one of the things that you're supposed to do with fire alarms is they have that little button on them. And you can go to that button, and you can push it, and it goes beep, beep. That tells you that your fire alarm is capable of going beep, beep, beep. But I don't really care whether my fire alarm is capable of going beep, beep, beep. What I want to know is if my house is on fire, does my fire alarm go beep, beep, beep? And probably all of you have had this sort of experience where you're like cooking and you set something on fire in the kitchen and the fire alarm is there going, yeah, nothing to see here, no, it's all fine. And you're like, but my kitchen is on fire. Under what circumstances would you actually start making noise? So there is this sort of uneasiness. And I always sort of think, I wish I had a way of testing my fire alarm a little bit more than just making sure it can go beep, beep, beep if I push it. Because in a fire, it's not like the fire is going to go up and push the button. So what they sometimes do in institutions, has anybody seen one of these? Yeah, there's a few nods. What it is, it's like a cup, and it's sort of a cup on a long stick. And a person will go along, and they'll they put the cup over the fire alarm, and then they push a button, and it makes a little poof of smoke, and then the fire alarm goes beep, beep, beep. So it's not the same as setting the whole building on fire, but it tests the thing that you really care about, which is in the presence of smoke, does the fire alarm go beep, beep, beep? So that's sort of similar to what's going on with a contract test. So if I go back to my sweater, so this is the knitter. The idea is I've got a sweater resource, and I've got some unit tests for it already. So, whoops. No, that wasn't what I wanted to do. Right, we'll just go there the old way. So I've got a unit test which has a little bit of a mock set up. So it says, when I get a request into my mock for wool, then return a white skein. And then I've got a test which says, let's make sure that my thing actually does the right thing, which is given white wool, it gives me a white sweater. So let me just copy that and call it sweater resource contract test. And the other thing I'm going to do actually, you can use Pact with Quarkus. I'm demoing with Quarkus because I work on Quarkus. You can use Pact with Quarkus, but if you want to see the really sort of cool features like continuous testing, it's best to use the Quarkus Pact extension. So I will do Quarkus ext add Pact consumer, and that will add it to my POM, but it means I don't need to worry about like editing the XML or anything. So now, in my contract test, it's this. You can see I started by copying my unit test because I want to test the same kinds of things, except instead of doing my setup with a mock, I'm going to do my setup with Pact. So I get rid of this and bring that in. And so there's a DSL. Fix those. And fix that. So I'm doing a similar thing to what I did with my other mock declaration, but I'm just doing it using the Pact DSL. So I say, given this input, I'm going to return this kind of JSON. And then there's one more thing I need, which is some JUnit annotations to say, when I run my tests, I want to run with the Pact runner. So now, with that, you can see my tests are running. So far, this hasn't actually helped me discover the problem because I've started running contract tests on the consumer. The tests are all green, but reality is broken. Where it starts helping is when I start sharing the contract between my consumer and my provider. So when I ran this test, it created in here a folder called Pacts. And in there, you can see there's this JSON file, which I won't show you the full details of, but it's taking the output of that DSL and the output of running the test and saying, okay, so I expect you to behave in this way. I can copy that Pact across. And there's a bunch of ways that you can share the Pact between the consumer and the provider. There's a Pact broker, which is a separate service, and so everything can talk to the Pact broker, and then it gives you nice dashboards. Or what some teams do is they just check it into the other team's CI. I'm only running locally, so I'm just going to copy it across in the file system. So I copy it across on the file system. Now I can go to my farmer. Oh, did it not copy? Thank you. No, you're right, it totally didn't copy. Why didn't it copy?
You're missing facts.
Oh, yes, you're right. Thank you. Hooray. Thank you. That would have been awkward to debug. Right, so now when I go over here to my farmer, I can do the same thing. I can add my extension. So I'm going to add the Pact provider. And now in my wool resource, I'm going to add a new test. I don't know what it is. There's some magic about live demo. That keyboard shortcut you use all the time, your fingers go in the wrong place. So I'm going to make a wool resource contract test. Then I'm going to bring in my template. So what I've got here is I've got a functional test, but I'm not actually having to write very much testing at all. I'm just having to do a little bit of setup to say, this is the port on which I expect my endpoint to be running. Pact, please help me out by running this test for me. And then this is a JUnit test template to say, use Pact to run the tests. Pact will refer to that JSON file and figure out what we should do. So now if I do Quarkus dev, I should see, it will run my tests, and I should see, yes, I've got a failure. So the Pact output is a little bit weird in the continuous testing console, so let me go. Ooh. If I go up, 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 up. There we go. So it's saying, hey, look, you're supposed to have color with a U, and you don't have color with a U. Something's wrong. So this is exactly what I want, which is that I'm just running unit tests, but by sharing that JSON file with the expectations, I can catch the case where I've done something terrible. So when you see Pact tutorials, what they'll often do, and when I've seen Pact use, or when I've seen people use Pact, what they'll often do is, in the consumer side, you know that your contract is going to be shared to the provider, so you know that you're helping to test the provider. So when you get your mock back, you say, okay, so I'm going to make sure that there's a field called color on this thing that I got backed, but it's just a mock. You literally just defined it 3 lines above, so there's no point checking the behavior of the mock. What you want to be doing is exactly the same as you would in a normal unit test, where you're using that mock to help you check the behavior of your code. And yeah, if you look on the internet, it is a trap to be aware of, that you do see this pattern where people are just making assertions about the mock, which is a complete waste of time. So yes, do not test the mock. The mock is your friend. It is not the thing you are supposed to be testing. With Pact, one of the things that's maybe not ideal about Pact is you do have this separate JSON format. And of course, a lot of teams already have an investment in OpenAPI. So then the question is, couldn't I just use OpenAPI to validate things? And for like this kind of example, like what I just showed, yeah, you totally could have caught that with OpenAPI. But there's some deeper validation that you can do with Pact that you can't do with OpenAPI. So let's have a look at that. So the way my application works is, if I order a white sweater, I get a white sweater. If If I order a brown sweater, I order a brown sweater. If I order a black sweater, I order a black sweater. And, oh, whoops, I forgot to fix my problem. If I order any of these sweaters, I get the wrong sweater. So let me just go back, refactor, do the refactor, and then so now if I order a black sweater, I get a black sweater. And similarly, if I order a gray sweater, I get a gray sweater. So what happens if I order a pink sweater? I got a white sweater. I didn't get a pink sweater. What's going on? The problem here is a misunderstanding. What the farmer code is doing is if it gets an order in for wool, if it gets an order for black wool, the farmer goes and it looks for the black sheep and it shears the black sheep. If it gets an order for white wool, it goes and it shears the white sheep. There is no such thing as a pink sheep, so it cannot shear the pink sheep. So somewhere there was a misunderstanding where we needed to have a conversation to say, hey, if it's pink, maybe you go out to the dyeing service or something like that. But because we haven't done that exploration of what the behavior is supposed to be, we have this glitch where we just get a white sweater. So you can see I was worried about my demo, so I have a backup of the demo in slide form, so we'll skip over that. And you may say, this was not a realistic demo. Anybody using an API would be aware that there is no such thing as pink sheep, but you can see that it would be quite easy, actually, to miss the fact that there was a missing service that was only needed some of the time. And in fact, it is also the case that there are such things as pink sheep. So this isn't a digitally generated photo. This is an actual photo. There's a festival in Britain called the Latitude Festival, and they dye the sheep. So pink sheep are a thing. And I've got, I won't show you I can show you the code for changing the test to add another test that says there should be pink sheep, and then we get the failure. But I think you can see that would work. And more generally with Pact, you can do assertions that say, when I give you this input, I want this output. So you're not just saying, I expect the shape of your JSON to be like this. And you can do the same for error conditions as well, which is quite useful. So for example, I've had problems in the past where we had a couple of different versions of a code base, and some versions of the code base returned 204 if something was missing. Some returned 404 if something was missing. Both are quite reasonable ways to handle the error case, but the calling code needs to be different. The calling code needs to know which it's dealing with. And so sometimes if you just sort of say, okay, I expect a 204, and you write your code on that basis, you're going to have a problem, again, in production. You're going to have a problem in the field that you didn't notice beforehand. So there's a few ways that you can do contract testing. In general, you always need a provider. Hopefully, your API has a consumer, and then the contract is the thing in the middle that allows you to verify that provider and also act as a mock for your consumer. How do you generate that contract? You could write it by hand, but in general, what you're going to want to do is you're going to want some tooling to do it. So Pact allows the consumer to declare a contract in the exact same way that it would declare a mock, and then you can share that. You could use something like the Pact file, which is quite rich, or you could just use something like OpenAPI, which is a bit less rich. If you're using something like OpenAPI, then you can use schema thesis to do the validation. There's another tool called microservices, which is quite cool, which again uses OpenAPI to do that validation. And then again, if you're using to provide your mock, you could be using Pact. You could use, if you're using OpenAPI, Prism is a good option, and microservices is a good option. With some of these tools, like with Prism or with Microx, what they'll do is that they'll have a separate little service, which is a mock server. With Pact, the mocks just run in the same process as your unit tests. Then you can also start doing some other cool things. So once you have your contract, you could generate your open API from your contract. That sort of saves a hassle. Or you can go in the other direction and you can be contract first and you can generate your code from your open API specification. Some of these tools give you a dashboard. So Pact has a Pact broker. Microx has a dashboard. So again, you can look at your whole system and you can say, okay, well, what tests are failing? What tests are passing? Who's being tested against who? And your architecture diagram will also fall out of those tools. If you're using something like OpenAPI and your provider is sharing its specification, that's what's known as provider-driven contract testing. So the idea is that the provider sends out the spec and you only have those arrows there, and the OpenAPI will be generated from what the provider does. That has some advantages because it's using OpenAPI. Everybody knows OpenAPIs. It also, one of the things that we see with consumer-driven testing, which I will show you in a moment, is that the consumer can break the provider's CI. If the consumer says, I want this new endpoint that returns me pink sheep, then they push their contract, and then the provider's going, what? I never promised you pink sheep. Why is this contract in my CI? Sometimes that's a good thing. Sometimes that's not a good thing. The other sort of advantage of this is that if you're a provider and you're doing an API that hundreds of people are using, you probably don't want to have all of them pushing into your CI. You don't even know them. So this is a much more sort of anonymous way of broadcasting a contract. But it's got some disadvantages as well. If I have an OpenAPI specification and I publish that, and then I realize that there's this method that's really annoying to maintain, how do I get rid of it? I don't really know if anyone's using it because I'm not getting any input from my consumers. So I could just take it out and tell people that it's tough luck, but I would much rather have had the knowledge because maybe nobody's even using this method, and then I could get rid of it without even having to have a deprecation conversation. And I mentioned that you can't really get the sort of the functional depth with something like OpenAPI that you can with Pact. The other way of doing it is consumer-driven contract testing, which is what Pact is. So the idea is that the consumer defines the contract, and then that's used to verify. So again, it's the same idea, but there's the provider isn't defining the contract, it's only the consumer. So you get that richness. The provider, instead of having to develop everything that they think someone might need, they know exactly what's needed. So they can develop to what's needed instead of having to develop everything. But it has the disadvantage that you have this new format, you have the Pact contract, and you also have to have a conversation with your consumers. So if you don't know who your consumers are, this is never, ever going to work. With both of them, what's a really nice thing to do is to do this sort of a similar model as with TDD. So you do contract first. Even if the provider is the one providing the contract, they define the contract and then do their implementation to that contract. If you want to know more about contract first development, there's a nice article by the Red Hat App Dev team. They don't talk about Pact, but they talk about the open API flow, so the Prism and the schema thesis, and it's quite a good resource. And yeah, I mentioned that you can do Pact, Microx. There's Spring Cloud Contract, which is another sort of provider-driven one, or you can use open API with Prism and schema thesis. We've had a whole bunch of Quarkus talks today. This slide is the slide of what you have already missed, unless you were there. So if you have a time machine, you could go back and watch some of these talks, except for we have one more talk today after this one, which is Sergey is going to be talking about security, because of course we always leave security to last. So that will be over in MC2. And then finally, if you would like the slides, they're at that QR code, and there's a link to the sample code as well there. And with that, thank you very much.